Good afternoon. My name is Ben Solarski. I am the Operations Coordinator for BlueScope Steel in the cake making department. Today I want to talk to you about my project, which is restoring the heat on ovens 60 and 61 to flues 1 to 4. Cake making is a department of BlueScope. We are located in Port Kembla, New South Wales. Coke making makes a product called coke, which is carbon, an ingredient in making steel. A battery is the heart of coke making, where coal is inserted into an oven. It is then baked for around 18 hours at 1200 degrees Celsius, which results in a product called coke. A battery consists of 50 ovens, which hold approximately 42 tonnes of coal each. Heating is a department in coke making. They are responsible for heating of the ovens. This is achieved by using gas and monitoring the temperatures of each individual oven so they are not too hot or cold. This ensures the optimal coke size and quality of the coke for steel making or exporting. I want to talk about the background, issues and aim of this project. Over the last 3 years, there has been heating issues with ovens 60 and 61. The heating department report low temperatures in these ovens causing coal not to burn properly. Multiple repair attempts have been made in the past, but to no success. No action project plan has been made in the past with repairs made sporadically. Coke making loses revenue and increases costs from non-efficient ovens. BlueScope is at risk of fines from emissions from these ovens into the environment. Oven 61 has a cracked frame contributing to heating issues. There are 4 different areas of staff responsible for repairs who have not been working together and communicating. These pictures show the current state of our flues. The picture on the left gives an example of a good heating flue. It has good glow, good colour. The picture on the right is dark, which shows there is not much heating in this flue. These pictures show the current state of the oven walls. The picture on the left shows a dark floor on oven 60. This dark area should be glowing with heat. The picture on the right shows a dark wall with arrows pointing. This again should be glowing. This is a diagram of our waste heat boxes. Our waste heat boxes supply gas and air into an oven for combustion. On the left, you can see bus flues. They contain 5 cells. These cells can build up with debris and require regular cleaning. On the bottom, you will see an ascension pipe. This supplies gas into the waste heat box and can also build up. On the right, we see mushroom valves. These require regular maintenance and cleaning. This is an overview of our repair history on these ovens. These pictures show a blocked register. A register provides gas to the oven. As you can see with the arrows, the gas passage is blocked. This next slide shows the register after it's cleaned. It shows the gas passage is open. These pictures show coal spillage on our ovens from oven 61 and 60. On this slide, I have gathered data from the past showing the temperature history on these ovens. As you can see, from 2016 to now, these ovens have been getting colder. This graph gives a temperature profile of oven 60. On the left, you can see the arrow pointing to a low heat area. In the middle of the circle is temperatures of a high heat. This means we are overcompensating heat for the low end of the oven. And this graph shows the temperature profile for oven 61. Again, the arrow points to a low temperature. The circle also shows a high temperature, which also means we are overcompensating for the low area of heat. This graph is taken from our Coke Guide camera. It indicates oven 60 is one of the lowest temperatures on the battery. This graph indicates the pushing torque or amount of force needed to push out oven 60. A good oven will need little force. This graph indicates a high area at the start of the push, which means the coal is not coking. This graph shows the pushing torque for oven 61. There is a high peak in the middle of the oven. This could indicate a refractory or brickwork problem. The goals and objectives of this project is to restore normal operating temperatures and heat to flues 1 to 4 on oven 60 and 61. This will optimize coke size and quality to raise revenue for export. This will reduce costs by eliminating coal wastage from ovens. It will also stop delays in production caused when coal is spilled from oven doors. It will eliminate environmental issues when coke is removed from ovens. Eliminate raw gas escaping into atmosphere by repairing brickwork around the ovens. And the goal is to ensure all heating areas, mechanical, refractories, and operations work, communicate, and accept responsibility. This is an estimate and cost savings from the process engineer. He estimates there is a cost saving of around $46,000. Over the next few slides, we will look at events for these ovens. Events is a system used by BlueScope to identify problems. Here it says that the temperatures have been low on oven 60 and 61. These events talk about spillage and emissions from the ovens. These events also talk about coal spillage from oven 61 and 60 and raw gas escaping. This event for oven 61 indicates there is a crack in the frame and it is getting bigger. 61 also has a lot of coal spillage. Some key elements to consider for this project include time taken to complete repairs. It is not one major job but multiple small jobs needed to repair the ovens. This consists of heating, mechanical, refractories and operations all doing work to repair. Loss of production when ovens are left empty for repair. The cost of repairing the flues. Possibility of going over budget if more damage is found. For example, flue repair cost increases from $50,000 to $250,000. The labour availability over Christmas holiday period. Current ongoing protected industrial action by wages staff. The importance of coordinating resource areas working together, ensuring no delays. This is the action plan for moving forward. We plan to repair the crack in 61 frame, install stainless valves and commence oxygen monitoring, clean the bus flues on oven 60, strip and clean the mushroom valves on 60, inspect regenerator brickwork and waste heat box seals for air leaks, clean top of regenerators on oven 60 and 61, look into possible FSP temperature monitoring during pushes, discuss changing supply gas for heating of these ovens, and scheduling the next meeting to discuss. In conclusion, by repairing and restoring heat to oven 60 and 61, it will result in better coke size and quality to the coke making department. This will reduce delays in production by reducing the amount of coal spillage created. There will be less likely occurrence of environmental emissions from properly coked ovens, resulting in increased revenue to BlueScope through export coke sales. Thank you.